Okay, in this video, we'll look at Chapter 19, Worksheet 2. This worksheet is the next theorem which we will learn, which is this thing called the midpoint theorem. So this is a very, very useful theorem. So let's look at what this theorem is about first. The midpoint theorem essentially says that it is if there is within a big triangle like this, okay? Let's say if I have a line that joins in the center of this triangle, and this line here, it cuts, let's say, this side here into two. So, and it cuts this side here, AC, into two. And this line is such that it cuts at D and E, whereby D is the midpoint of AB and E is the midpoint of AC. When I draw this line that connects the two midpoint of these two sides together, this line here, DE, must be parallel to BC. That's the first condition. That if I can conclude that if I know that D and E are the respective midpoints of AB and AC respectively. And the second part is that the length of DE is half the length of BC. Okay, this is a very special property that we can only conclude only if D and E are midpoints of the side AB and AC respectively. So this thing is called the midpoint theorem. So let's look at a very simple proof on how do I prove this using the midpoint theorem using similar triangles. Okay, so if I look at this, right, if I look at this triangle here, I will use, for this case, I'll use the SAS similarity test. I note that angle BAC here in this big triangle is an angle DAE is the same, because so therefore this is the first thing I can write. Okay, angle BAC equals to angle DAE. This is a common angle, which is angle DAE. Okay, so this is the A test. Okay, and then after that, we can also conclude that since I know that D here is the midpoint of AB, by ratio, I know that the length of AD is half the length of AB. So if I were to form AD over AB, I know that this is also equal to, in this side over here, since that E is the midpoint of AC, it is equal to AE over AC. And this ratio is very clear, is that it is 1 to 2. Okay, 1 over 2. For both AD over AB and AE over AC. So therefore, over here, the reason why is because in this case here, we know that D is the midpoint of AB, and I also know that E is the midpoint of AE. And that's how I can conclude this ratio. So therefore, very simply, therefore I can conclude that triangle ABC is similar to triangle ADE, and this is by the SAS similarity test. Okay, so once I've done this conclusion here, I have proven that triangle ABC and triangle ADE are similar. So therefore, this can make the conclusion that since they are similar, I know that this angle here must be the same as this big angle here. These two angles must be the same. So that's the next conclusion I can get. Okay, so therefore, angle ADE is equal to angle ABC. And in this case over here, and both angles are corresponding angles. And therefore I can make the next conclusion that this tells us that therefore DE, this line here must be parallel to BC. DE must be parallel to BC. Okay, and this is one part we have shown in the first property that we want to show, that DE is parallel to BC. Okay, and the next property we want to show is that DE is half of BC. So we can make use of the similar triangle property again, since triangle, or we can just call it since the triangles are similar. Since triangles are similar, I can make the following ratio again. I know that since the ratio of the sides are all the same, I know that AD over AB is 1 over 2. AE over AC is also 1 over 2, which means that DE over BC is also 1 over 2. So therefore, this tells us that AD over AB is equal to AE over AC, and it's also equals to DE over BC. And this ratio is 1 over 2. And if I focus on this equation here alone, I can therefore obtain that DE is equal to half of BC. And this is the second property I've shown once I've proven that these two are similar triangles. So these are the two properties that we have shown. This is property 1 and property 2. That once I can identify that I have 2 points which are the midpoints of the respective sides, and I form a line here, therefore DE must be parallel to BC, and also that the length of DE is half the length of BC here. Okay, so this is the very simple proof. This alternative proof, you can also read it yourself. I won't be going through them. Let's look at example 1 directly now. How do you apply the midpoint theorem into questions when we see them? Okay, so let's look at example 1. Example 1, we know that E is the midpoint of AC, so E is the midpoint of AC over here. If I want to mark it, I can draw this line here. Okay, and therefore, it is also the midpoint of BD, so I know that BE is the same as ED. Okay, and F is the midpoint of BC, so this is another midpoint that we have. Prove that AB, which means that this line is parallel to this line, which is parallel to this line. Okay, so let's start by looking at this triangle here first. Triangle ABC. Okay, I know that E and F are midpoints of AC and BC respectively, and I draw a line like this. So therefore, how to present this for part 1? Okay, since I know that AE is equal to EC and BF is equal to FC, I'm looking at this side equals to this side and this side is equal to this side. Therefore, in this triangle over here, I can make the conclusion that therefore AB must be parallel to EF. And the reason for that, you must write this reason down. This is by the midpoint theorem. Okay. Next part, I will look at this triangle instead. Okay. Once I look at this triangle, I know that E is the midpoint of BD, F is the midpoint of EC. So therefore, since BE is equal to ED and BF is equal to FC, the next conclusion I can draw is that therefore EF must be parallel to DC. This is also by the midpoint theorem. Okay. Therefore, from here, since I know that AB is parallel to EF and EF is parallel to DC, therefore I can make the conclusion that therefore AB, EF, and DC are parallel to each other. Okay, and this is how we make use of the midpoint theorem to show that the lines are parallel. Okay, this is for part 1. Now let's look at part 2. Part 2, I want to show that EF, this length of this EF is 1/4 of the length of AB plus CD. So how do I show that? Okay, so we can make use of the midpoint theorem again. From here, by the midpoint theorem, I know that since I look at this triangle again, this triangle here, okay, since AE is equal to EC and BF is equal to FC, the next property of the midpoint theorem tells us that therefore EF is equal to half the length of AB. Okay, I need to emphasize that this presentation here is very important, and also stating that the reason that you know this is by the midpoint theorem. Okay, this is very important, in presentation. So please make sure you have these reasons stated very clearly. Okay, next part. Same reason by the midpoint theorem as well. Since I know that BE is equal to ED and BF is equal to FC, I can also make the conclusion using the length property that EF is equal to half of, in this case here, EF is half of DC or CD, whichever, okay? Maybe I'll write it CD since the question here, write it as CD, so I'll write as half of CD instead. Okay, so from here now, we can now form the conclusion AB plus CD. Okay, because over here I have a AB plus CD, right? So essentially what this question is asking us to find is that 4 times EF is equal to AB plus CD. Okay, so let's find what is AB plus CD. In this case over here, therefore, AB plus CD is simply equals to, based on this equation here, half AB equals to EF. So therefore, it is 2EF plus 2EF as well. Okay, so AB here is 2EF. CD here is also 2EF based on these two equations here. Okay, therefore, I can now conclude that, therefore, AB plus CD is equal to 4EF. Therefore, EF is simply 1/4 times AB plus CD. Okay, and this is for example 1 part 2. And therefore we put a shown or proven. Okay, proven. In this case also here I'll also put a proven because this is a proof question. Okay, let's now look at example 2 now, the last example for this worksheet. For example 2 here, in this diagram we are given that these two angles are the same 90 degrees. E is the midpoint of AD and F is the midpoint of AE. Okay, prove that triangle ABE, so let's highlight this to be clear. I highlight triangle ABE. This is the triangle I want to show. Triangle ABE and triangle CACD, this big triangle here, are similar. Okay. So I want to, how do I do that? I think this is a very, very common type of proving question again. It is to show common angles, because we can clearly see that I have one common angle here and know that this angle is equal to this angle. So therefore for part 1, okay, I'm looking at in triangle ABE and triangle ACD. I first know that angle ABE is equal to angle ACD. Remember to match the vertices, and this angle is 90 degrees. This is given by the question. Okay, next one, I know that angle BAE is equal to angle CAD. Okay, this is a common angle. Okay, then I've shown using my AA similarity test that therefore triangle ABE is similar to triangle ACD by the AA similarity test. Okay, this is for part 1. Okay, then now in part 2, I want to show that B is the midpoint of AC. So let's look at this. From this question here, I can see that given from the information given the question, I know that since these triangles are similar, I've shown that they are similar already. Okay, and from this part over here, I see that E is the midpoint of AD, which means that if I write it in terms of ratio, AE over AD. Okay, since E is midpoint of AD, then I can make the conclusion that AE over AD is equal to 1 over 2. Okay, therefore this tells us that therefore I can also make the conclusion that since triangle ABE and triangle ACD are similar, I know that the ratio of AB over AC is also 1 over 2, since in similar triangles, the ratio of the corresponding sides are the same. So therefore, I can therefore make the conclusion that therefore, AB is equal to half of AC. And from this ratio, this will tell us that therefore, B is the midpoint of AC. Okay, so this is a very important conclusion. Since I know that AB is half of AC, I can conclude that B is the midpoint of AC. Okay, then now the last part, let me minimize this. Okay, now for the last part, part 3. Part 3, I have show that BF here is half of CE here. Okay, so this is very simple. I just use my midpoint theorem. Since I know that B is the midpoint of AB and F is the midpoint of AC, then we can use the midpoint theorem. Since AB equals to BC and AF equals to FE, okay, therefore, I can conclude that BF is simply half of CE, and this is by the midpoint theorem. So that's a very simple way to solve example 2 part 3. Okay. Okay, then now for the last one, I will now finish up with practice question 1. You can go back and try yourself first. It takes almost 2 minutes to finish this practice question. Then once here, you can continue this video to see how to solve practice question 1. Okay. If not, let's look at practice question 1. Okay, practice question 1 here, how to apply the midpoint theorem. In this question, we are given that G is the midpoint of AB and F is the midpoint of BC. So I want to show that AC is parallel to BD. So let's start. I first look at the triangle first. Cause midpoint theorem, we must always look at a triangle. So in this case, I can look at this big triangle here. In this big triangle, I know that G is the midpoint of AB, F is the midpoint of BC. So therefore, in triangle ABC, okay, since AG equals to GB and CF is equal to FB, these are all given by the question because I know that these lengths are the same. Okay, therefore I know that GF is parallel to AC. Okay, and this is by the midpoint theorem. Okay, now I've shown that these two lines are parallel. Okay, and since I know that AC is parallel to GF, and GF and GE, they lie on the same line, so therefore this concludes that. Therefore, we can conclude that AC is also parallel to GE. Okay, and then from here, by the question, since it's given that G is parallel to BD, we can conclude that since AC is parallel to GE and GE is also parallel to BD. This is given by question. Okay, therefore, AC is parallel to BD. I have proven what the question wants us to find. Okay, so this is a very simple application of how to use the midpoint theorem. You must always state, show that there are midpoints first, then apply the midpoint theorem to either use the parallel property or the length property. Then you can make sure you state the reason here to make sure the marker knows that you're using the midpoint theorem. Okay, so that's all for this worksheet. Please go back and finish up assignment question 2, just a very short question to finish and to apply your understanding of this midpoint theorem. So this will be the end.